Hey everybody, it's Ripley again. We're going to yap a little bit about section 1.7 out of the text called parametric equations and their graphs. Basically, you've seen parametric equations before back in pre-calculus, but let's dance with these just a little bit. If you recall, the problem with regular old functions is if we want to describe the movement of something, then if we're going to describe it with a function, then it has to pass the vertical line test, okay? But what if you have, say, a fly crawling around the surface of a coffee table? Well, clearly, that doesn't look like a function. This is a not function, all right? So there's no way for me to describe the position of the fly with respect to time as a function. So what parametric equations do, they're very clever. What they do is they describe different points at time, different points. So x as a function of time, let's say at time 1. So this point right here would be x of t1, y of t1. This point, right there. This point right here would be, say, x at t2, y at t2, etc. And this point right here would be x at t3, y at t3. In other words, what we do is we define x and y concurrently together as functions of time. So instead of a function, f of x equals x cubed plus the 4x plus 1, what we would do is we would simply say there would be an x of t and a y of t. Now, when the function itself, when the equation itself is a function, it's really simple to redefine these in terms of parametrics. Watch. I can just define this. I can let x of t be t, and I can let y of t be t cubed plus 4t plus 1. All right? Excuse me. However, if I don't have a function, like a circle, I'll show you a nice little trick here. Again, we've seen these before. A badly drawn circle. Let's say that this is x squared plus y squared equals 4. So we know that this is a circle of radius 2. Now, I can define this as functions. I can define the top half of the function. If I solve for y, I would get y equal the positive square root of 4 minus x squared. But that only gives me the top half. If I want the bottom half, then I would also have to say y equals the negative square root of 4 minus x squared. All right? The problem is, this isn't even a piecewise deal. This is two separate functions happening simultaneously. However, parametric equations give us the ability to take care of two birds with one stone. Now, I'm going to show you a little something here. If I let, for example, if I were to say let, I don't know, watch this. Let's say that x of t equaled sine of t. And I let y of t equal cosine of t. Now, this is going to seem like a non sequitur. It's like, why are you talking about these things? I'm going to show you something here. Watch this. Algebraically speaking, if I were to square both of these and add them, what would I get? Well, I'd get x squared plus y squared equals sine squared t plus cos squared t, which last I checked, sine squared anything plus cos squared anything is always 1. Hey, guess what I made? I made a circle. If I graph these, and we're going to do this in just a sec on our TI, I got a fancy new piece of equipment too. We can do it on our TI, which is really cool. If I were to graph these, I would end up with a circle of radius 1. Now, can you see what I would need to do to make my circle of radius 4? Well, let's check it. If I let x of t equal, what do you think? I'm going to square everything, and what I need is a 4 over here. So wouldn't I just have to go 2 sine of t? And y of t equals 2 cos of t, then wouldn't I end up with x squared plus y squared equals what? 4 sine squared t plus 4 cos squared t. Factor out the 4, and you get sine squared t plus cos squared t, and voila. Oh, guess what? You have a circle of radius 2. Now, let's graph these. Let's make sure that I'm not talking crazy, okay? So bear with me just a sec. I'm going to grab my fancy schmancy. Look at this. I got myself an online or an on-computer calculator. All right, so watch how this works. I'm going to go to my mode, and I'm going to change it to parametrics. All right, so I got to toggle down. I can't do this, unfortunately, with my pointer. And I'm going to hit enter, and then I'm going to go up here. Now, watch what happens. Look over here in this screen. This is exactly the same as your calculator, so it's just not happening simultaneously. I've got an x of t, or x1 of t and a y1 of t. All right, now let's go back over here real quick, and I'm going to page back, and let's graph. We're going to graph this guy right here in both forms, and I want to see if I get the same thing. Now we're going to get a little change in here, and I want to show you why that is, but let's make sure that we're real comfortable with our calculator. So first things first, I'm going to put that over there, and I'm going to let x of t be t, and I'm going to let y of t be, what do I have to do? I got to go t cubed over plus 4t plus 4t plus 1. All right? And then I'm going to hit zoom, and I'm going to hit standard, which is 6, just in case. All right? And that's what I get. Now, that looks a little bit funky, doesn't it? Let's look at that. This is what I get right here. Well, I know that this is going to be cubic, so I know it's going to go on forever. Why did I only get this little chunk? Well, let's change modes, and let's graph it in regular mode, okay? And let's put it in function mode real quick. And we'll see what happens, and we'll see if we get any sort of discrepancy. All right, so first things first, what was it? X cubed, so x cubed, all right? And then I'm going to go plus 4x, and you can do this along with me, hopefully you are, plus 1, and then I'm going to hit zoom standard. I always do that. It's just a good habit. Now watch what happens. Why are they different? Well, let's go back to mode, put it in parametric again, and see what's going on here. And I think that this is the best way. Look at that. See how your graph changed? It only got the right-hand side. Well, why is that? Well, check it out. Go to your window. Oh, look at that. T has limits on it as well. Okay, now check it out. Your x min and your x max are still negative 10 to 10. Your y min and your y max are still negative 10 to 10. But look, because t is a variable in this, it's like we're dealing with 3 variables instead of just 2. Notice what my t min is. It's t min is 0. T max is 6.28. My spidey sense tingles a bit when I see 6.28. That's 2 pi. But let's change T min to, I don't know, what do you think? Let's go negative 10. And let's change T max to, I got to clear it out first. Oh, look at that. I didn't even need to change it, did I? Look down here. My curve changed to exactly what I needed it to be. All right? So what happened was, because we only started T at 0, watch, when T equals 0 over here, I know that Y is going to be 1. So we only got the part of the curve that started when Y equaled 1. Watch, I'll change it again. If I go back up here, and instead of negative 10, I clear it out, and I hit 0, watch what happens. I only get that right-hand side that starts right at 0, 1. Isn't that cool? Okay, now let's go back here for just a sec. I'm going to move this up, move this over, and let's do these circles. However, I'm going to reset this. When I put this in, I'm going to reset it to my zoom standard, and let's see if we can figure out what happens and why it happens and all that good stuff. So we're going to play with this guy right here. All right, so I'm in, what mode am I in? Oh, I'm right where I need to be. So we'll go y equals, I'm going to clear this out, and we've got x of t is 2 sine t, and y of t is 2 cos t, 2 cos t, whoops, I need to clear this out, don't I? 2 cos t, all right? Now, I'm going to go zoom standard, which is zoom 6, and look at that, I got my 0. Now, this is a little bit goofy because if you notice, my scaling on my x and y axis aren't the same, so it almost looks, well, it doesn't almost, it looks elliptical. I think I can do, let's see if I can do, I think it was zoom box, didn't it? I forget. It doesn't really, no, I don't want zoom. Zoom square. Let's try zoom square and see if it does it better. Zoom square. Look at that. That's better. Ooh, nice and pretty. All right. Now, check it out. If I go back to window and I look, notice t starts at 0. So when t is 0, the sign of, if I know that x of 0 equals 2 sine of 0, which is 0, and y of 0 equals 2 cos of 0, which is 2, which means when I graph this thing, it starts at 0, 2. Now, let's see what happens since we're going from 0 to 2 pi. Let's say, I'm going to click over,